to a into r to the power n minus 1. One thing to mention, r is not equal to 1. Of course, that is not 0. In case of r equal to 1, you see, all terms will be equal, and in case of r equal to 0, only one term will be there. When r is greater than 1, we take this one. When r is less than 1, we take this form. Both are equal. If we consider particular cases, we will see the result will be same. Since r is the common ratio, therefore first geometric mean will be r times ar. Second geometric mean will be r square times of a. Following that, nth geometric mean will be ar to the power n. Welcome to btosacademy. Welcome to my maths class. Students, viewers, today I am going to start GP, geometric progression, then harmonic progression, first geometric progression. In arithmetic progression, we saw the difference of two successive terms are always equal. In case of geometric progression, actually I start taking an example. Here, first term is 1, and we find three by 1. If we take the ratio of second term to first term, or third term to second term, or fourth term to third term, we see that ratio is always constant. This constant ratio is called common ratio. That means a term is constant multiple of the preceding term. 3 is 3 times of 1, 9 is 3 times of 3, 27 is 3 times of 9. In such cases, these numbers are said to be in GP. 1, 3, 9, 27, are said to be in GP, geometric progression. Now, general form. If we take first term A, that is the convention, and common ratio R, then second term will be AR, third term will be AR square, fourth term will be AR cube. Now we have to find the nth term. We see first term is A, second term is AR, third term is a r square. Now we note the power of r. In the second term, power of r is 1, and that 1 can be written as a r, keeping term number in mind, it will be 2 minus 1. And for the third term, it will be a r to the power, term number is 3 minus 1. Similarly, T4 will be a r cube, and that is equal to a r to the power 4 minus 1. Now the first term, since r is absent, therefore a r to the power 0. And that is, keeping in mind the term number can be written as a r to the power 1 minus 1. That means power of r is 1 less than the term number. Power of r is 1 less than the term number. Therefore, following the symmetry Tn will be equal to a r to the power n minus 1. That is the first formula. Nth term of GP having a first term and r common ratio will be equal to a into r to the power n minus 1. One thing to mention, r is not equal to 1. Of course, that is not 0. In case of r equal to 1, you see, all terms will be equal, and in case of r equal to 0, only one term will be there. Thus, we have deduced nth term of the GP ar square, ar cube is given by a r to the power n minus 1. Next, issue is how to find the sum of first n terms of a GP. To find the sum of first n terms of the GP ar square, ar cube. Let Sn be the sum. Therefore, Sn equal to ar square plus up to nth term. Already we have determined nth term is a r to the power 1. Now, our observation is, if we multiply both sides by r, then left hand side will be r into Sn, and on the right side the products will be ar, in this case ar square, in this case ar cube, etc., and it will be a into r to the power n. Now, the trick we apply, we write the right terms shifting one place. Follow that. Therefore, r into n is equal to First product will be here. I write that shifting one place. And this product will be, if we multiply this by r, it will be a r to the power earlier one n minus 1, and this product will be a r to the power n. Follow the trick. We have retained the terms shifting one place towards right. Now I take the difference. Subtracting the result will be Sn within brackets 1 minus r. Sn minus r into Sn, I have taken Sn common factor. Now on the right side, what we find, these terms within first and here nth one for the second row, all are cancelled. Therefore we get just a minus a r to the power n. Therefore Sn 1 minus r is equal to, taking a common factor, 1 minus r to the power n. From that, Sn is equal to, numerator is a into 1 minus r to the power n, denominator is 1 minus r. This is the sum of first n terms of the GP. Now we take two cases. When r is less than 1, then we take this form. When r is less than 1. When r will be greater than 1, we just multiply both numerator and denominator by minus 1, and then we get this form. When r is greater than 1, we take this one. When r is less than 1, we take this form. Both are equal. If we consider particular cases, we will see the result will be same. In case of r less than 1, this will be, actually we are multiplying both numerator and denominator by minus 1. Therefore, the value will be same. Now we are going to find geometric mean. Actually, two cases arise. Case 1, two given numbers are, say, A and B. Case 1, geometric mean of A and B. That means there will be just one mean, geometric mean in between A and B. If X be the, we write in short form GM, geometric mean, then A, X, B are in GP. If X be the mean of A and B or in between A and B, then if we write as it is mean, therefore it will lie between A and B, then AXB will be in GP. Therefore, as per the property, ratio of second and first will be equal to ratio of third to second. From that, x square equal to AB. Therefore, x will be equal to plus minus root over AB. Therefore, geometric mean of A and B is plus minus root over AB. Actually, you have learned in earlier class mean proportional of two numbers, and in case of geometric mean, you see the same. That means in case of geometric mean or mean proportional of two numbers, same. Here we just use the term geometric mean. Actually this is mean proportional of A and B. Now we see two signs, plus and minus. When plus will be applied, when minus will be applied. If the given numbers be positive. If the given numbers be positive, then their geometric mean or mean proportional will be positive. When note, when A, B both positive, then G geometric mean, in short GM, greater than 0. Therefore, GM of A and B is root over, you can mention plus AB. And when AB both are negative, when A, B both negative, then GM geometric mean is less than 0. Therefore, GM of A and B is minus root over AB. Note this, but if one is positive and the other is negative, we cannot determine the geometric mean. Remember this one. When AB both positive, then geometric mean will be plus root over AB, and when AB both are negative, then geometric mean will be minus root over AB. Next, we are going to find geometric means. That means there will be two or more means in between AB. Case 2. Let G1, G2, G3, Gn be geometric means in between A and B. Two or more than two means, we denote those means as G1, G2, G3, Gn. Now, if we place those means in between A and B, what we find? Then A, G1, G2, G3, Gn, B are in GP, geometric progression. Now if we write those means in between A and B, these numbers will be in GP. Therefore, G1 will be AR, G2 will be AR square. Following this, Gn will be equal to AR to the power n, where R is the common ratio. Since R is the common ratio, therefore first geometric mean will be R times AR. Second geometric mean will be R square times of A. Following that, nth geometric mean will be AR to the power n. Now, how many numbers are there, or how many terms are there? N geometric means are there along with first and last. Now, B is the n plus 2th term of the GP, and as per formula, it is A R to the power n plus 1. N means are there, and A and B together, number of terms will be n plus 2. Therefore, B, that is the last term as per formula, A R to the power n minus 1, already we have deduced earlier. Here n is n plus 2, from that we get B equal to A into R to the power n plus 1. Therefore, R to the power n plus 1 is equal to B by A. From that, we can find the value of R. R is equal to n plus 1th root of B by A. N plus 1th root of B by A, which can be also expressed by B by A whole to the power 1 by n plus 1. Thus we have got the common ratio. Now, after getting the common ratio, we can easily find the geometric means. Therefore, first geometric mean is G1 AR, means this one, A into B by A whole to the power n plus 1. Second geometric mean G2 A into B by A whole to the power 2 by n plus 1. Third will be G3 A into B by A whole to the power 3 by n plus 1. Following the symmetry, Gn, that is the nth geometric mean, will be A into B by A whole to the power n by n plus 1. Thus we have found geometric means in between two given numbers a and b.